Okie dokie. Unit 4, Lecture 3, we are going to polish off our discussion of ionic bonding and naming rules. After this one, we will move on to some molecular bonding and naming rule stuff. Very exciting. Okay. Transition metals. So this is the kicker, and this is not super difficult stuff. It's just another layer of complexity in the whole picture of how we name and write formulas for our ionic compounds. All right. So you ought to remember that our transition metals are those metals in the middle of our periodic table. All right. And you guys don't really know about your electron levels and sublevels yet, but they have electrons residing in that d sublevel, right? And because of that, it makes them a little less predictable in terms of how many electrons they're going to gain or lose, because they kind of have a long ways to go either direction to the nearest noble gas. All right. So because they're less predictable, we need to treat them slightly differently. All right. I am going to point out right now, though, some of the transition metals are predictable. For example, silver and zinc and cadmium. Right. Those guys are always, silver's always going to be a +1. Zinc and cadmium are always going to be +2. At least always for us. All right, I guess there's always exceptions. That's the only always in chemistry, is there's always exceptions. But for us and what we do, we're just going to always assume that zinc's +2, cadmium's +2, silver +1. All right. So here's what I want you to do. I want you to pause the video. All right. I want you to find your periodic table. All right. And I want you to find a highlighter or a pen somehow to mark these guys right here on your periodic table. Because you know what I don't want to do tomorrow and the next day and a month from now and 6 months from now at the end of the year is when I say something about zinc. I don't want you to ask me, well, you didn't put the Roman numeral next to zinc. What's the charge, Mr. Huderberg? I'm going to be like, ding-a-ling, you're supposed to mark that on your periodic table. All right? I don't want to have that discussion. I want to have the discussion of not that. Anyways, so find your periodic table, pause, go find it, and you're going to highlight or mark or somehow indicate that zinc is always a +2 and cadmium is always a +2. Silver is always a +1. And I did go ahead and mark these guys too. Aluminum, we already knew aluminum's a +3, but gallium and indium, when we get down here to thallium and this right, that guy, they're not always going to be +3. All right. So I want you to mark this kind of little triangle of elements. Silver is always +1. Zinc and cadmium always +2. Aluminum, gallium, and indium are always +3. And I want those highlighted and marked some way so that you don't ever get confused about why I didn't put a Roman numeral next to silver. Because you're going to know, oh yeah, that's because silver is always +1. So pause and do it, and I'm going to know if you didn't. I'm going to know if you didn't. Did you pause? Did you do it? Did you? Did you? Did you? Okay, now we got these guys marked, right? Along with aluminum and gallium and indium, right? All the other transition metals, they're going to vary. Sometimes it might be a +1, sometimes a +2, sometimes a +3, 4, 5. Things get crazy down there, okay? And so we are going to write those differently. All right, they will get a Roman numeral, and I'll show you what I mean by that in just a moment. Iron oxide. Iron can be iron 2 or iron 3. Those are the most common ionizations for iron, right? Now, metals, again, all of our metals are always going to be positive, by the way. They're not going to end up negative, at least not in normal conditions. The parentheses tell us the charge of a cation, right? So all transition metals, except for zinc, silver, and cadmium, and then along with gallium and indium, will be noted with Roman numerals so you know the associated charge. So if I want you to write the formula for iron oxide, I'm either going to put a 2 next to the iron or a 3 next to the iron. And that will tell you then how to balance the charge using oxide, which is always a -2. Okay? Oxide. All right, so the Roman numeral 2 tells me that this iron is a 2+. Oxide, as we know, is a 2-. Iron 3 oxide, the Roman numeral 3 there, tells me that this is Fe 3+, and oxide is 2-. My corresponding formulas will look different. We should find that iron 2 oxide. So this guy right here, it's a +2 and a -2, so my crisscross is going to give me a 2 and a 2, but we remember, of course, that when it's a 2 and a 2, we reduce that to just FeO. So iron 2 oxide is just FeO. Right? Iron 3 oxide, on the other hand, right? I'm going to take my 3 with my crisscross applesauce method and put it with oxygen, 2 with iron, and that is Fe2O3 formulas, right? Now, if I had some experimental evidence, right, for this, like we did in the lab, I would notice that if it was iron 2, a 1-to-1 ratio of iron and oxygen would give me my most iron oxide, whereas if I had a 2-to-3 ratio, giving me the most precipitate, then that would tell me that iron 3 is my ion. Now, let's work backwards. If I already know the formula, right, we can determine the charge of the transition metal. So let's say I give you this formula and I want you to name it, right? Because iron is a transition metal, I can't just say iron sulfate. I'd be close, but I would not be giving the teacher or whoever enough information about that, because is that iron 2 or is it iron 3? Is look at the equation, right, to identify the charge. So we know sulfate, right, is a -2. That little 3 right there tells me this is iron 3 sulfate, okay? So when we name ionic compounds with transition metals, and if those transition metals are not zinc, silver, or cadmium, right, we need to indicate the charge of that with the Roman numeral. So just like I will give you that, right, if I want you to write the formula, you need to give it to me if I ask you to write the name. All right, and all you do is you kind of work backwards from the formula to figure out what that charge is. It's pretty simple. All right, that is it for this, right? So we guys are going to finish up Chem Quest 19 tomorrow. We'll do a quiz tomorrow, and then we're going to move on to molecular or covalent bonding and how we have to use different rules for naming and formulas for those guys. All right, keep to it.